accelerating material development via knowledge mining and hypothesis generation. In this demo, we are uploading everything needed to understand and improve refractory materials, that is, material properties, experimental results, formulations, process parameters, performance metrics, and simulation outcomes. I'll start by asking SoothGPT to summarize the datasets and show how they connect to demonstrate its ability to understand and tie all the pieces together before diving into specific questions. So let's have it explain how material properties like thermal conductivity influence wear resistance, or how sintering conditions impact experimental results. This helps show its ability to tie everything together before diving into more specific questions. With this prompt, we want to use the data to figure out the best material and processing steps for something as tough as steel ladle linings. The goal is to strike the perfect balance between durability and cost-effectiveness while being clear about trade-offs. We can use the data to suggest a brand new material formula that performs better under tough thermal cycling conditions. It's like spotting a trend in what's worked before and taking it one step further with science-backed recommendations. We're looking at how to make refractories more eco-friendly by cutting the carbon footprint without losing the performance you need. It's about finding the sweet spot between sustainability, cost, and durability for high-temperature applications. Now let's ask the AI to pull everything together into a table, showing which materials are at the highest risk of failure, why they might fail, and what changes could help. This makes it easy to see actionable recommendations at a glance and compare materials side by side.